Now let's go to see a couple of examples. Okay. Here's an example. From a normal population with a population standard deviation 8, a sample size 10 is taken, and the sum of mean is 52. A. Build a 90% confidence interval for the population mean. Now, we know this expression for the lower bound and upper bound, and mean sample mean plus minus the z-score multiplied by the standard error. Okay, then you bring in the actual value. Sum of mean, which is 52, go here, plus minus z-score. Z-score that correspond to 90% confidence. So now let's go to normal table. Okay. If you want to be 90% confident, that means that you have a 90% probability in the middle. 90% in the middle. Okay. This table gives us half of the distribution. Half of the 90% is 45%. 45%. So within this normal table, you need to look for a percentage closest to 45%. Okay. Let's see. 44.84, 44.95. Okay. 44.95, 45.05. Okay. One or two will be okay. This is 44.95. This is 45.05. One is lower than 45. One is higher than 45. And truly 45 is somewhere in between, but we don't have that value. Let's just choose one of them. You can either use 44.95, either use 45.05. If you use 44.95, that would give you a z-score 1.6, let's see what's the heading here, 1.64. But if you decide to use 45.05, that z-score would be 1.65. So you and your classmates may not have the exactly same z-score because you probably choose to use a different percentage here. Let's use this percentage, 44.95. That will give us a z-score 1.64. Let's come back here. So z-score that corresponds to 90% confidence interval is 1.64. Oh, okay, that's 1.64. And multiplied by the standard error, which is population standard deviation divided by the square root of sample size. Okay. Then you complete calculations. One is minus, which give us a lower bound. One is the plus here, which give us upper bounds, and you express the interval appropriately. Lower bound to the left, upper bound to the right. Okay? So it's fairly straightforward. Now, B, build a 95% confidence interval. 95% confidence interval. Now, 95% confidence interval, we know the population standard deviation, therefore we use this same expressions of lower bound and upper bound. We know this value, we know this value, we need a z-score. We need a z-score that corresponds to 95% confidence interval. Let's go to the normal table. 95% confidence interval, that means that in the middle you would have 95% probability, and half of 95% is 47.5%. So within this table, you need to find a percentage number, 47.5. 47.5. Let's see if we find 47.5. 47.5. Exactly, you have this value, 47.50. See? So this percentage corresponds to a z-score 1.96, 1.96, come back, 1.96, and that's where the z-score goes. Multiplied by the standard error. The complete the two calculations, you obtain the lower bound and upper bound. Okay, so that's so come back to this slide. So we just show two examples of how to build the confidence interval with z-scores. Now, let's summarize what we learned. We learned how to build a confidence interval using z-scores. We use this expression to calculate the lower bound and upper bound that involved z-scores and the accurate standard error. We use this expression to build the lower bound and upper bound when we know the population standard deviation, and the sample could be any size, large or small, doesn't matter. Here the standard error is calculated by using the population standard deviation divided by the square root of sample size. Many times, we do not know the population standard deviation. So many times, we do not have this condition. We do not know the population standard deviation. Think about that. If you do not know the mean, the question is, we try to use this interval to estimate the population mean. So that means that we do not know the population mean. But if you do not know the population mean, how come you know the population standard deviation? We know the population standard deviation is calculated by using, in part, the information of the population mean. But if you do not know the population mean, how do you calculate population standard deviation? Just kind of these two conditions are in conflict. So a more likely scenario is that we do not know the population standard deviation. Then what happens if we do not know the population standard deviation? Can we still use the same expression to find the lower bound and upper bound of a confidence interval? When that happens, we can still use z-score, but we use this expression to calculate the lower bound and upper bound. In this expression, we have the sample mean is the same as this one, plus minus z-score same as this one. But here, instead of using an accurate calculation of standard error, we have this term. This term is called the estimated standard error. The estimated standard error. The estimated standard error is calculated by using this equation. This S is the sample standard deviation. Since we do not have the population standard deviation, we can just use sample standard deviation as estimate of population standard deviation here. Population standard sample standard deviation is used as estimate of population standard deviation in this equation. Okay. In the place where the population standard deviation is supposed to be, you plug in a sample standard deviation. So the result is that you calculate an estimated standard error. This is the true standard error, and this is the estimated standard error. Okay, so you put this term in this equation. But you can still use z-score as long as the size of the sample is large enough. For example, larger than 30. Okay, so you would use this way to calculate the lower bound and upper bound when you do not know the population standard deviation. but the sample size is larger than 30. But you had to calculate an estimate standard error by using a sample standard deviation. So that's the difference between this expression and this expression. Both expressions use sample mean z-score, but this expression uses standard error, this expression uses an estimated standard error.